Today we're going to learn how to write equations using slope-intercept form. And now I'm going to do two types of slope-intercept form. I'm going to have what I call basic slope-intercept form and then more advanced slope-intercept form for later. But I'm going to start with the basic of slope-intercept form equations. So this is all about writing equations. I'm going to have two basic questions for slope-intercept form. These may look challenging, but as far as equations go, they're not the most complicated thing we will see. You'll see way more complicated stuff. So the first question is write the equation of a line in slope-intercept form that has a slope of negative 1/3 and a y-intercept of negative 9. In the second equation, you're looking at a graph, and you have to write the equation. So before we begin, let's talk about the basic notes for writing equations. When we are writing linear equations, we will need two pieces of information. Okay? So when we're writing equations, we need two pieces of information. We need a slope and we need a point. Any point will do. But when it comes to slope-intercept form, a particular point is more helpful than others, and that particular point is the y-intercept. But in general, when we're writing equations, we need a slope and a point. For basic slope-intercept form, the two things that we need are still the slope, that's why we call it slope, and the y-intercept. That's the other piece of information that we need. So those are the two pieces of information to write in slope-intercept form. If we had a slope and a point, we could find this information. If we had the slope and the y-intercept, we don't need to find anything. We're pretty much done. It's just a matter of understanding how the equation looks. So let's talk about slope-intercept form. Slope-intercept form looks like this. It's pretty famous. Y equals mx plus b. Now the m and the b are used for a variety of reasons that I kind of think don't make much sense, but standard practice says we use them. You'll find in other countries different letters for the M and the B. But in all the other countries around the world, we're still using Y, and we're still using X because that's your general ordered pair, X comma Y. For our country and most other European nations, Y equals mx plus b. So what does this form mean? Well, the form gives us information about the line that we are looking at. Okay, remember we talked about slope being a description of a line. Well, the equation also gives us more information. Okay, the equation itself gives us slope, which is m, believe it or not. M will tell us the slope of the line. And remember, slope determines how slanty it is. And it also tells us, this form also tells us what is the y-intercept. Where does that graph cross the y-axis? That's what that means. The y-intercept is where the graph crosses the y-axis. Remember, the y-axis goes up and down. The y-intercept is where the graph crosses that y-axis. So when you see an equation in this form, it gives you information. It gives you the slope, whatever is the coefficient of x, and it gives you the y-intercept, which is the constant. Okay, but you know something is in slope-intercept form when you have y equals mx plus b. So let's look at the first question in the basic slope-intercept form questions. We're writing an equation of the line in slope-intercept form that has a slope of negative 1/3 and a y-intercept of negative 9. This is straight substitution. Remember, slope-intercept form of a line is y equals mx plus b, where y stays y, x stays x, the other things give us information. The m comes from the slope, the b comes from the y-intercept. So we start with writing our equation again. Y equals, instead of writing m, we have to look, do we know what the slope is? And when we read the question, we see, yes, the line has a slope of negative 1/3. We can then substitute negative 1/3 for m. The x stays x, the plus stays plus, and then we look at the b. So we continue reading. Well, what is the b? B stands for y-intercept. We continue reading, and it has a y-intercept of negative 9. So the y-intercept is negative 9. So we substitute our b with negative 9. So this is a straight substitution problem. Now the only thing is we got to clean this mess up. This plus minus doesn't make any sense. It doesn't jive well. So we're going to clean up that mess and write our final equation in slope-intercept form. Y equals negative 1/3 x. Now what is plus minus all about? Well, what's a positive times a negative? It's a negative. So it's just one sign. We have y equals negative 1/3 x minus 9. That is our equation in slope-intercept form. And when we look at this form, y equals this, we can tell the slope is negative 1/3. Remember, it goes down 1, right 3. And the y-intercept is negative 9 on the y-axis, intercepting at negative 9. So when we start using this later for graphing, we'll know what to do. So that is basic slope-intercept form, the most basic we can find. Now, what about this second equation? What about the second problem? Now we have the picture of a graph. Write the equation of the line in slope-intercept form that represents this graph. Now we have the picture of the graph. Well, remember, there are two things we need to write an equation of a line. We need a slope, and we need a y-intercept. And so we have to look at this graph. Can we tell the slope from this graph? Well, we need to remember what slope is. Slope is rise over run. And then when we look at this graph and we try to figure out what is rise over run, we have to look at the 2 points that we're given here. Okay, 2 ordered pairs. Now we can find the coordinates of these ordered pairs, the xy coordinate, and find slope the way we did before. We're doing change in y with change in x, but there's a simpler way. We can simply count the rise over the run. If we look from the bottom point to the top point, we can see that it's rising 1, 2, 3, 4, 5, 6 units. It is rising 6 units. So positive 6 for the rise. It's rising 6 units. And from that rise of 6 units, it's running to the right 1. So it went up 6, to the right 1, excuse me, and to the right means it's positive 1. So for the rise, we went up 6. For the run, we went right 1. There is our slope. But remember, we always simplify our slope. So the slope is 6 over 1, which is 6. Okay, so we're working a little bit backward from when we were describing what slope means. We have found the slope of this line. Now, what about if we counted down? What if we went from this point to this point? What if? What if? So I'll use that in blue. Let's pretend we had rise over run, but instead of counting from the left point to the right point, we counted from the right point to the left point. I'll use this in blue. If we start at the rightmost point, we would go down 1, 2, 3, 4, 5, 6. We would go down 6. From that down 6, we would go to the left 1. So if we looked at the line going from right to left, which I strongly advise against, but what if we did? We would see down 6 is negative 6, left 1 is negative 1, and guess what the slope would be? The slope would still be positive 6. So even if you're looking at the graph the wrong way, from right to left, which you shouldn't, you should always look left to right, even if you're looking from right to left, you will still end up with the same slope, a slope of positive 6. Now what about the y-intercept? Now the y-intercept is where the graph crosses the y-axis. So if we look at the y-axis, this is the y-axis. Where does the graph cross? Crosses right here. There is our y-intercept. You're looking right at it. But where in the world is that? On the y-axis from 0, that's positive 1, positive 2. So the y-intercept on the y-axis is at the ordered pair 0, positive 2, or we could simply call that a y-intercept of 2. So now, remember what we're trying to do here. We're trying to write the equation in slope-intercept form. We found our slope. We have our y-intercept. Can we write the equation in slope-intercept form? Well, remember slope-intercept form. Y equals mx plus b. So our y stays y, the equal stays equal. The m is the slope that we found. The slope that we found was 6. We substitute 6. The x stays x. The plus stays plus. The b is the y-intercept, which we found to be 2. And we substitute the 2. And this is the equation of the line that we're looking at. So to write it again with just one color to make it look nice and pretty. There is the equation of that line in slope-intercept form. So this was our graph. This is the equation of that graph. Now, what does a graph represent? A graph represents the set of all ordered pairs that makes this equation true. So every single dot on this line represents an ordered pair that makes this equation true. And we'll talk more about that later. But in the meantime, we now know the basic use of the slope-intercept form. Thank you.